start recording. Okay, so we've just completed normal. So the next family of distributions that we have is gamma. Okay, now we only need to do a specific case of gamma distribution, which is the exponential distribution. Yes, I've taken note of your doubt. At some point, we'll do it when we have slightly more time. Okay, so a random variable x is said to have exponential distribution with parameter lambda, and lambda is supposed to be positive. If the PDF of the random variable is given by this function. Lambda into e raised to power minus lambda into x for non-negative x and 0 otherwise. Okay, so how is this distribution going to look like? This is not a symmetric distribution. So if we have x over here and f of x over here, it's going to look either like this, or okay, or it's going to look like this, or this. Now it depends on the value of the parameter lambda, how the distribution is going to look like. So this one is for lambda equal to 1, this one is for lambda equal to 2. Now just look at the function and tell me what these intercepts are going to look like. Okay. So the vertical intercept of the red curve with lambda is equal to 2. What is this function going, this value going to be? Yes. So what we do is we have origin as 0 both ways. We put x is equal to 0 and lambda is equal to 2. So we get 2 here. Similarly, if we put x is equal to 0 and lambda is equal to 1, this will be 1. This should be 0.5. and the expected value of exponential distribution. The procedure of calculating the expected value is same. Just put x here, fx dx minus infinity positive infinity. For the particular case that we have, f of x is given by this, and we can put the limit starting from 0, because less for values of x less than 0, f of x is 0. Okay. You can do this yourself. It will come out to be 1 by lambda. Those who have just joined, we're doing the exponential distribution. Variance of exponential distribution. Again, the expression is x minus mu square f of x dx from minus infinity to positive infinity. The expected value is 1 by lambda square into lambda e raised to power minus lambda x dx. This will also come out to be 1 by lambda. Okay, so what comes out of this is that both the mean value and the variance are same at 1 by lambda. The CDF of exponential distribution, again we'll use the same convention, uppercase F for the cumulative distribution function of the random variable x. It also has just one parameter lambda. For negative values of x, the probability is 0. The sum is also 0. For non-negative values of x, is this function e raised to power minus lambda into x. Now uses. So let me just bring in Poisson. So used to, let me not use the word obtain. Let me say Poisson distribution is used to model the number of events occurring in a unit of time. Okay, so we tackled problems like how many, what was it, emails were expected to be received in a given unit of time, 1 hour, 2 hour, things of that sort. Exponential turns this problem around, and he'll say that, okay, let me read the doubts. It will be 1 by lambda. the variance. You can do it. Correct me if there's an issue. Exponential distribution is used to obtain expected time elapsed between occurrence of two successive events. Okay, it's not the only use, just like we saw in the Poisson, that we start off by uh, modeling time, but other continuous variables can also be used, or exponential distribution can also be used to model other continuous variables like distance, area, etc. So formally, let me write it this way. And what is alpha here? Alpha is the expected number of events occurring in 1 unit of time. Okay, so take it from here, that parameter alpha t and that number of occurrences, it's independent. Hmm. I think you are right on this count. Standard deviation will be 1 by lambda. This will be 1 by lambda square. Okay. So this is it, and already told you the approach is slightly different when when we're doing continuous distributions. So unlike other discrete ones, we don't start off with how a particular experiment looks like, then how do we use the rules of probability to come up with a distribution. Here we straight away have a distribution. So we're skipping the part in how does a particular distribution fit a particular problem. That portion is given to us. So what we have to do is move from looking at the technicalities of the distribution straight away to solving problems, and the portion that a particular distribution has to be applied to a particular problem, this is given to us. Please read question number 59 from the text. So we're given a random variable x, which is the time between two successive arrivals. At the drive up window of a local bank. ठीक है जी, बैंक के पास भी ड्राइव अप विंडो है. And we're given the fact that x follows exponential distribution with lambda is equal to 1. Part A, we're asked to figure out what the expected value of x is. That is straightforward. Lambda is equal to 1, so the expected value is also 1. Then next we need to figure out what the standard deviation is. Variance, we've corrected ourselves, so I have corrected myself. That it's 1 by lambda is also 1. And then we need to figure out. Now, first tell me, what would this probability be?
So lambda e raised to power minus lambda into x.
0. Straight away. Continuous distribution. Okay, whichever it is, the probability that the random variable takes on a particular value is always 0. Okay,
Okay, okay.
so this is going to be same as this, what we've given, and this is 1 minus e raised to power minus lambda into x, which is our expression for CDF of exponential random variable. So first we are asked in part C, the probability that the random variable x takes on values less than equal to 4. Now we just put in value of lambda, which is 1, and then x, which is given to us. This will come out to be 0.982. Part D.
But then, sir, why we are given the PDF function if the like each value equals to x is 0?
Can you repeat? I missed that part.
So I'm saying that if each value which is equals to x, like x is equals to 4 is 0, then
Mhm.
like what is the use of this PDF function then?
Okay, now go back to the first class. I said you must never read this as probability. It's just density. The probability is area under the curve. Okay, so for any particular value, the area under the curve is 0. You need two distinct points to have a positive area. Does that make sense now?
Okay. Yeah, yes, sir. Yes. Got it. Thank you.
Okay, so the probability that the random variable x takes on between values between 2 and 5 is just we subtract the probability that the random variable takes on value less than 2 from the probability that the random variable takes on values less than 5. इसके बाद तो it's mechanical. E raised to power minus 2 minus e raised to power minus 5, 0.129. Okay, any problems? Please read the next one, question number 60. We're given the random variable which now measures distance and measures distance in meters. Blah blah blah, somewhere we're not concerned. And we're given the fact that the random variable x here follows exponential distribution with lambda is equal to 0.01386. So need to figure out the probability that the random variable x takes on values less than 0. Straightforward. Values less than equal to 200, again nothing special, and then okay, no problem in any of these. Let's move to B. So we are being asked the probability that the random variable x is larger away from the mean by 2 standard deviations. Greater than mean by 2 standard deviations. So we just put mean and 2 into standard deviation. This will be x greater than or equal to 3 by lambda 0.01386. This is 1 minus probability x less than, this comes out to be 216.5. So after this should not be a problem. 1 minus e raised to power minus 216.5001. Okay, in part C we need to find the median. So process of finding the median is usual. You just put f of x is equal to 0.5 and then we solve it for x. If we have f of x here, this starts, okay, and some a is going to be parallel. This is 0, this is 1, 0.5, and then we solve it for a particular value of x. This is how we find the median. E raised to power minus x 0.01386. This is 0.5. After this should not be a problem. Just always take log both sides and you'll get your x. Now I will only ask you to do till question number 61. Question में कोई problem नहीं है. You should be able to do 61. Now let's see what doubt Arshika has. Okay, before that let's stop recording.